Hey, what's good, everybody? I hope everything is going well. Welcome to the Incredible Academics YouTube channel, and today we're going to be looking at a slightly different topic. Remember, we've been focusing on calculus. Now we're shifting to sequences and series. Okay, so that's today's topic: sequences and series. So this is the topic that we're going to be starting with. So that's like the very first topic that you guys are going to look at in grade 12. Okay, and good thing is it's probably the second last chapter in grade 11. Okay, so let's get right into it. So sequences, we're going to start with the arithmetic ones. Okay, we're going to start with arithmetic sequences. Sorry about that. So arithmetic sequences. Yeah, well, just gonna do a quick introduction, and let's suppose that we're given the sequence 1, 4, and then 7, and then 10. All right, and then it keeps on going on and on like that. Right, so now you want to check, okay, is this sequence arithmetic? All right, is it arithmetic? Meaning that now you need to be very familiar with the properties of an arithmetic sequence. Remember, an arithmetic sequence, properties of an arithmetic sequence. Really, the main property is that Tn plus 1 minus Tn is equal to D. Alright, in other words, pick any two terms within your sequence. That difference is going to be the same. Alright, there's no any consecutive terms, and obviously when we say consecutive terms, we mean terms that follow each other. Can you see 1 and 4 follow each other, 4 and 7 follow each other, 7 and 10 follow each other? But if you find the difference between 7 and 1, these don't follow each other. There's a term in between. So in other words, the difference between 7 and 1 is not going to give you the D. Okay, so let's do a test with this one. T2 minus T1, you'll be getting what? That's 4 minus 1, which is 3, and then T3 minus T2, that's 7 minus 4, we're still getting 3, and then T4 minus T what? Minus T3, that's 10 minus 7, so we're still getting what? We're still getting 3. So we can see that the differences between consecutive terms is constant. Okay, so we also know that there's a general formula for arithmetic sequences, which is as follows: Tn is given by A plus n minus 1 D. So this is when you are trying to find the nth term or the general term. All right, this is the formula that you're going to use, and you need to know exactly what the D is and what the A is. We know that A is the first term of the sequence, the first term of the sequence. So to find the general term, all you need is the A and the D, because it has to be in terms of n, right? And what else am I leaving out? So A is the first term of the sequence, and remember what we use the general term for. For instance, let's suppose that they're asking for term number 500. Do you understand? So without the general formula, you won't be able to find term number 500. Otherwise, it will take you like 5 days or so, trying to find term number 500. So that's why it's easier for us to use the general formula. Also, when you are given a specific term number and then you need to find its position, then you're going to use the general formula. So it's very important for you to be able to calculate the general formula. But can you see that to find the general formula you need your A and your D? So I mean it's easy to figure out what the A is, but it's not always obvious what the D is. In other words, you then need to sort of like find the differences between the consecutive terms. You pick any two terms that are consecutive, right? And then you find their difference. You start with the biggest one and then subtract the smallest one. So the biggest one, we're talking about the position. You see, this is 1, this is 2, this is 3, and that is 4. So you take the one with the highest position, and then you subtract the one that comes just before it. Then you get your D. Alright. So normally this is what we do. We'd say, okay, let's find the differences. Let's find the differences. Then you'd see that, okay, we're getting the same number throughout, and that's like the characteristic of the arithmetic sequence. So now let's go right ahead and find the general term for this sequence. Okay. All right. So remember, we've got 1, we've got 4, we've got 7, we've got 10, right? Da-da-da. And then now we know, okay, A is 1 and the D is what? The D is 3. In other words, to get to the next term you have to add 3. So 1 plus 3, that's 4, 4 plus 3 is 7, 7 plus 3, that's 10, so on and so forth. So once you've got your A and your D, then you can find your general term. Okay, so Tn is equal to A plus do this. So Tn is equal to A into n minus 1 D. So let's substitute A, which is 1. Let's substitute the D, which is 3. So this becomes what? 1 plus 3n minus 3. So our answer is 3n minus 2. Alright, and when we separate, so Tn is equal to 3n minus 2. Remember, 1 is term number 1, right? So meaning that when we substitute 1 in place of n, we should be getting a 1. So T1 is equal to what? 3 1 minus 2. T2 is equal to 3 2 minus 2, and then T3 must be equal to 3 into 3 minus 2. T4 must be equal to 3 4 minus 2. So now this is what? 3 minus 2, that's 1. 6 minus 2, that's 4. 9 minus 2, that's 7. 12 minus 2, that's 10. You see? So meaning that this is actually the general term, because it enables us to generate the terms within the sequence, right? So that's just one way. If you're asked to find term number 100, you're just going to say, okay, if Tn is 3n minus 2, then term 100 is going to be 3 into 100 minus what? Minus 2. So that's 300 minus 2, which is what? 298. You understand? So you're not always going to be asked, okay, what is the you're not always going to be given the position and asked to find the actual term number. Right? Sometimes you're going to be given the term number and then you're asked to find the position. For instance, if it's known that there's this term which has got a value of what? This term which has got a value of 32998. That's the value, right? But we don't know what position that is. Okay, so in other words, a certain term number is equal to 2998, but we're just wondering, what's the n here? Is it term number 100? Is it term number 150? Is it term number 300? That's the big question. So we're just going to say, okay, we write down our general term, which is 3n minus 2. Right, we write down our general term, then we substitute the value, which is 2998, and then we solve for the n. Do you understand? So I mean, there's two ways to go about it. Then sometimes you're solving for the n, sometimes you're solving for the tn. Do you understand? So then minus 2 to the other side, that becomes what? 3000 is equals to 3n. Now you divide throughout by 3, n becomes what? 1000. In other words, term number 1000, right? Term number 1000 is 2998, right? And yeah, I'm gonna leave it here for now. Until next time.